Tech Cafe, where we make everything science, technology, engineering, and mathematics easy to comprehend, assimilate, fun, and entertaining. The main focus is to make it interesting and enjoying. Now, we have treated integration in the past, the techniques involved in integration. Now we want to talk about application of integration. Where do we apply it? Mainly, we apply it in one, calculation of area. Calculation of area. What type of area? The area between a curve and the axis of the graph. The area between the curve and one of the axes between the graph. Now look at this. When we look at it from this place, x, this is y. But we have a curve like this. Y equals mx. You can see that y is expressed in terms of x now. The area that you can calculate easily with this is going to be this. If you want to calculate the area between this place and this place, it's a different ballgame. There's another technique to do that. So the first area we can calculate is this. And how do we do that? Let's say this place is y, and this place x. Sorry, let's say this place is x, and this place is x plus delta x. So this place is y. This place is y plus delta y. If you want to take the area of this place, it's delta a. So delta a will be approximately y delta x, because this place to this place is delta x. That's it. So, but when delta x becomes, if you look at this area now, you know we took it as like something like a rectangle. For this place, this area here has made it inaccurate. That's why we put approximation here. So we can now see delta a over delta x is approximately y. But when delta x gets very small, you understand? The approximation becomes more accurate. Now let's make it, when delta x tends to 0, delta x will tend to dA dx. So at this point, when it is very small, so dA dx, you can say it's equal to y now. You can see. So from this, you can easily say that dA is equal to y dx. So our area now, because that will be the summation of all these small rectangles, but very small now, from this point to this point, to be equal to y dx. So a will be equal to y dx. You can see. So that is how we use it to calculate area. We can calculate several kinds of area when we understand the logic of this expression. Now, let's look at something. Now, before we go on, I also want to point out something. In this situation, you know, area is something we handle algebraically. So, if we have a curve like this, and a portion of the area comes under this place, this area will give us negative, because it is below the axis. Please take note of that. But if it is above like this place will be positive. This place is negative. So take note. So if you are going to calculate the area from this range to this place, if you do it straight, you are going to have it smaller than this one, because this one is subtracted from this. So how do we do it? You need to have the understanding of how the graph looks like, so you know where it breaks. And from that, you can take your areas equal accurately. Look at this now. If I want to take it, let's say this is x1. Let's say this is x1 and this is x2. So if I want to calculate this area, I have to calculate it from 0 to x1 y delta x, y dx, sorry, plus from x1 to x2 y, because this one will give you negative. Do you understand? This one will give you negative. So you have to make it positive and then add the two together. That try to explain about this. So we can use it to calculate area like this. I have explained this too. Another kind of area you can use it to calculate is area between two curves. Two curves. Let's look at now. Let's look at area between two curves. I will use this illustration. Let's look at area between a curve and a straight line now. See now. And this is y equals to fx, and this one is y equals to gx. If you want to calculate the area between these two, I will need to find this intercept. I will need to find this intercept. And how do I do that? I will equate this one and this one. Since both of them are y, the point at which the y here is equal to the y here is where they intersect. And after that, I can now say, okay, which one is bigger, which one is smaller? I will subtract the smaller one from the bigger one. You can see that of this straight line is smaller, and this one overshadows it. Let's look at how it goes. 1. Calculate points of intersection. From there, 2. Calculate area covered between the range for each curve. 3. Subtract 1 from the other. Now look at this. The point of intersection can be calculated by saying fx is equal to gx. So from this one we can get x1, x2. So we can get x1, x2. And after that, since I have known this one, let me look at this. See. Let's call this one A. Let's call it up to this stage A1. So it's going to be like this. This is A1. Can you see? So it's x1, x2, x1, x2. Can you see? So area between area is going to be A1 minus A2. So you can easily do the integration, mix everything together, and get the area between the two curves, or between a curve and a straight line. This also is like, this application is like coming back to find the area again, like getting original equation. How do I mean? Now, you know that if we have v, it will be the s dt. You can see. So it's continuation of getting area. Now, if I want to get the s, it will be v dt. So s is going to give me v dt. You understand? And if I have expression for v, let's say this is v, and this is t. So let's say v equals to function of t, and this is v. S, the distance, is going to be the area covered in. So you can see, so this is S. So it is still the same thing, depending on how you view it. But by doing your integration straight, you get it. You can get back to the original equation. That is what this one is. That is it. So, I don't really want to take much of our time. Let's look at one other application before we go into some exercises. Another application is looking at integration as summation. This is why you can use it in so many continuous, in calculation of sum of continuous variable. Look at this. Let's say this is y, and this is x, and we have it from this place to this place. You know, if I want this portion now, this place will be y, this place will be y plus delta y, this place is x, x plus delta x, and this place will be what? Delta x. This will be delta x. So if I have it in that continuous pattern, You know, y will be increasing, x2 will be increasing. In this situation, it's not always that it will be like that. Sometimes x will increase, y will reduce. Now, this portion, what this place will be is this area, just like we had before. This area here, A is going to give me, so this place, delta A, is going to give me y delta x. You know, it is not also accurate, just like the other one. This place here, look at it like this. This place here has made it inaccurate. So which means that for us to get very close to the accurate value, you have to make it very small. Very, very small. So for each portion to be okay, it means that the A will be approximately. This one too should be approximate. The A should be y dx. Because we are saying that delta x in this case tends to 0. So delta x tends to 0 then. Now, when we are adding all this area up, this one, you say, okay, this place is y delta x. Because we are making it very small. We are trying to add up the value within this place. Plus y1 delta x plus y2 delta x, and continue like that until you get to this one, y delta x. So, but now it is very small. So our A is equal to summation y dx. Yeah, delta x tends to 0. Okay? From, let me see, x1 to x2. So you can see this summation, by the time you look at it, it is also the same thing as the integration of y dx from x1 to x2. So please take it like that. This integration too can be viewed as summation of all the figures within this place. Think about finding sum of continuous expression like sine. You know, it's going to be like this. So you can find the area of this place, or the summation of all the figures within this place. You know, it is changing. Like what is this? This oscilloscope and whatever. You can find the sum of this thing, and it is still going to be the area within this place. That is it. So please take note of this. Summation of the things within this, or the figures here, is also going to be integration y dx. Now let's go into some examples. Now let's handle this example. It says find the area bounded by the curve y equals 3x squared plus 14x plus 15. The x-axis and the ordinate at x equals minus 1 and x equals 2. So if you look at this curve, it's going to be like this. So we are going to have it beyond this place. So at this point, we have x equals 2. And here, minus 1. So we have to find the area between this. You can see none of this portion comes below the curve. So everything is still above. So I can do it at once, straight. So our expression is y equals 3x squared plus 14x plus 15. So our area will be equal to y dx from 2 to minus 1, which is going to be 3x squared plus 14x plus 15. So once we integrate this one, it's going to give us x cubed over 3 times 3 here. Doing this for explanation's sake, we have plus 14x squared over 2 plus 15x from 2 to minus 1. This is minus 1. So let's cut 7, 15. So it's going to give me x cubed plus 7x squared plus 15 from 2 to minus 1. So we can just do this one straight. So this is going to give me 8 plus 28, 36 plus 15. I think that's 51. Minus is minus 1 plus 7, 6. Oh, this is 15x. Sorry. So that gives me 8 plus 28 plus 30. Minus 1 plus this plus minus 15. So everything is 75 units squared. So you can see this is the basic application of integration in calculation of area. Now let's look at another example. Now we have another example. We have it says determine the area of the figure bounded by the curve y equals to x squared minus 4. The x-axis and ordinate at x equals to minus 1 and x equals to 4. For this, we have the hint that certain part is below, certain part is above the x-axis. Now let's look at it. If y equals to 0, that is the portion where it equals the x-axis. X squared minus 4. So x squared is equal to 4. So x is equal to plus minus 2. So with this information, we can easily do our work. Which means that this is how the graph is like. So it means that one point is 2, one point is minus 2. So, and since it is x squared now, it is curving upward. If this one is negative, it will curve downward. So we have it upward now. So it's going to be like this. You can see. So let's just take this place as our 4. And this place as our minus 1. You can see. So which means that if I want to find the area, I will find it in 2 portions. From minus 1 to 2 and from 2 to 4. You can see. This part is not directly like this. You see. So one part is above, one part is below. Now let's calculate the area without wasting time. So area of figure bounded will be A1 plus A2. So it's going to be A1 plus A2. So we can easily find it like this. A1. So it will give us negative figure, but we know we turn it to positive. To add it or give it. So it's going to be x plus minus 4 from 2 to minus 5. So which will give us x cubed over 3 minus 4x 2 minus 5. So 8 over 3 minus 8. 8 over 3 minus 8 minus 1 over 3 minus 4. Yes, plus 4. So this gives me 9 units squared. Though it's negative. But you know, area should be positive. So I have 9 units. That is 8. So let me do it like that. So let's see A2. A2 will give us x cubed over 3 minus 4x from 4 to 2. And we know we have already know that of 2 here. So it's going to give us, let me calculate. So this gives me 10 to 3rd unit squared. So area bounded is equal to A1 plus A2. This is equal to 9 plus 10 over 3 is 19 over 3. So assuming we just did everything all through, we are going to get this one minus this one, and that would have given us wrong value. Now we have this. Find the area enclosed by the curve y equals 25 minus x squared and the straight line y equals to x plus 13. Now we have it like this. It's going to be something like this. You know, when we have it like this, y equals 25 minus x squared. So if it is 0, so you are going to have 25 equals to x squared. So x is equal to 5 or minus 5. So which means our curve is going to be something like this. So we have 5 in minus 5 in. So when x equals to 0, this base is 25. Now we have y equals to x plus 13. X plus 13. So we're going to cut it like this. The first step is to get the point of intersection as explained before. So let's quickly get point of intersection. Y equals x plus 13 and this is y equals 25 minus x squared. So you can see we have two curves. Y equals x plus 13 and y equals 25 minus x squared. So this line cuts this 25 minus x squared. Now let's find the point of intersection. One. Point of intersection. This will determine the limits by which we are to do our integration. That is it. Now let's quickly do that. So the point of intersection is when y here is equal to y here. So 25 minus x squared is equal to x plus 13. Then let me bring this here. So I can have x squared minus 25 plus x plus 13 is equal to 0. So x squared plus x minus 12 plus 0. So if we have to do this, we have x squared plus 4x minus 3x minus 12 equals 0. So x into x plus 4 minus 3 into x plus 4. So x minus 3 and x plus 4. So from here you know our point of intersection. That's the point of intersection are point x equals to 3 and minus 4. So we have this place minus 4 and this place 3. So that's the first step. Now the next step is to find the areas. So calculate it to be from, for this one, a1 will be equal to 25 minus x squared dx from 3 to minus 4. a2, that is area below, is going to be from 3 to minus 4. That's x plus 13. You can find this separately. You can find this one separately and then subtract. Or you can merge everything since the range is the same. So I can now say a is equal to a1 minus a2, which is going to give me 3 minus 4 from 25 minus x squared dx minus x plus 13 dx from 3 minus 4. Then I can make it like this. 3 minus 4. This one minus this, that's 12 minus x squared minus x. So dx, it should be 12x minus x cubed over 3 minus x squared over 2 from 3 to minus 4. That's how it is. Let's now solve this to get the final answer. So our final answer is 57.2 units squared. Yeah, 57.2 units squared. Thank you. So see you in the next video. If you have not subscribed, kindly subscribe, share, comment, and follow in our other units. Give us suggestions and please share. Let enough people know. Those are the kinds of encouragement you can give us. Comment to encourage. Thank you very much. If you need any of my service or you need clarification on whatever we have done or suggestion, you can do that through any of the channels in the description or through the comment section. I appreciate you. Thank you very much. I appreciate your assistance. See you in the next video.